Hey everyone! Today we're going to learn how to solve a system of equations using the substitution method. Now remember, when we're solving a system of equations, what we're essentially finding is to figure out that solution or the coordinate point x comma y that makes not just one equation true, but for both equations. In other words, if I were to graph two equations, or in our example, two lines, we want to figure out when these two lines intersect or connect. That point, which we call the point of intersection, is also called the solution to the system of two equations. So here's an example. We have y equals 2x minus 4. That's a linear equation. And we have another one, 2x plus 3y equal to 12. That one is also a linear equation. Now let's go ahead and solve the system. So both of these we can actually graph. So let's go ahead and graph the very first equation. Now for that very first equation that we see that we have the y-intercept of -4. And we have a slope of 2. So if you were to graph those two lines, let's see what we get. So we have a graph with a y-intercept of -4, and then we have a slope of 2. Okay, so that is the graph for the very first equation. Now what about the second equation? Now that equation does not look like y equals mx plus b, or in slope-intercept form. So before we graph this line, we can actually turn this into slope-intercept form, or y equals mx plus b, to figure out the slope and the y-intercept. So let's go ahead and get y by itself here. So to isolate y, I'm just going to subtract 2x from both sides. That brings down the 3y is equal to 12 minus 2x. Now these two are not like terms, so they do not combine to be 10x. It's just 12 minus 2x. Okay, now to get y by itself, all I gotta do is divide by 3 for all terms that we see. So there we go. So we have y is equal to, well, 12 divided by 3 is 4, and then minus 2 over 3, or negative 2 divided by 3, is just negative 2/3 x. And there you go. We just rewrote the second equation into slope-intercept form. Y equals mx plus that b value. So let's go ahead and graph that equation. So this equation starts at 4, and the slope is negative 2/3. That means I'm going to go down 2, over to the right 3. And there we have it. So what is the solution to the system of two linear equations? Meaning, if I were to graph those two lines, what is the point of intersection? We see that the point of intersection is 3, 2. That point is a solution to both equations. Now, there's a bunch of solutions to the very first equation on the line, and there's also a bunch of solutions to this equation on the line. But when we're solving a system of equations, we're looking for the solution to both equations on the line. In this example, it's x equals 3, y equals 2. That point is a solution to both equations. Now, we're about to show you how to find the solution to the system equation using an algebraic method called the substitution method. So sometimes graphing is not efficient like we've done before. So instead, let me show you how to use the substitution method. Okay, so now here's the exact same example, but this time we're going to use the substitution method to figure out when these two lines intersect, or the solution point. Okay, so the first step, we have to make sure that one of these two equations has a variable isolated. In this example, we already see one equation with the variable y isolated. Y is already solved for. But what is y equal to? Y is equal to 2x minus 4. Since y is equal to 2x minus 4, we can then substitute 2x minus 4 into y, because that is what y is equal to. So 2x plus, and then this says 3 times y. But what is y equal to? Y is equal to 2x minus 4. So it's 3 times 2x minus 4. This whole equation has to equal 12 from the second equation. That first step was a process called the substitution. We substituted 2x minus 4 into y, because that's what y is equal to. Okay, so now all we have to do is just solve this equation. So the first step is I'm going to use the distribute property. So we have that 2x from here, and then distribute the 3 to both terms. So 3 times 2x is 6x, and 3 times minus 4, or negative 4, is negative 12. Now, when we solve this, notice that there are like terms on one side of the equal sign. So these two combine to be 8x. And then all we gotta do is solve for x. (12 plus 12 is 24, and then to get x by itself, we're going to divide them equally by 8. So x is equal to 3. Now that makes sense, because when we graphed those two lines earlier, we saw that they both connect or intersect at x equals 3, y equals 2. So this solution does make sense. So now how do we figure out the other part of the coordinate point, the y? Well, since we already know x equals 3, we can just plug that point in, or substitute this point in, into either of these two linear equations. It actually does not matter which of these two that you picked, because remember, both of these lines are the same or intersect at x equals 3. So let's go ahead and just choose the easiest one. So I'm just going to choose that very first equation, y equals 2x minus 4. Since x is 3, let's go ahead and substitute x as 3. So 2 times 3 is 6, minus the 4, we have the y value of 2. So now what is the solution to the system of equation? The solution then must be 3, 2. That is the solution to the system equation. Okay, so here's another example of a system of two linear equations, and we're going to use the substitution method to figure out the solution. Okay, so now y is already isolated. Y is equal to x minus 2. Since y is equal to x minus 2, we can substitute x minus 2 into y, because that's what y is equal to. So we have negative 2x minus 3 times y. But what is y equal to? What is y's substitute? Well, since y's substitute is x minus 2, we can replace y with x minus 2. This whole expression has to equal negative 9. And there you go. That is your first step. Now we're just going to solve for x. So we have negative 2x, and then we're going to distribute negative 3 into both terms. Negative 3 times x is negative 3x. Then negative 3 times negative 2, double negative makes a positive, so it's going to be positive 6 equals negative 9. Now, can we combine something? Are there like terms that we can combine? And yes, negative 2x minus 3x combines to be negative 5x plus 6 equals negative 9. So then get x by itself. So we're going to subtract 6 both sides, bring down that negative 5x. Now negative 9 minus 6 is negative 15. Then we're just going to divide both sides by negative 5. So x is equal to negative 15 divided by 5. Again, when you divide two negatives makes a positive, so it's positive 3. Okay, so now we found out that the intersection point of these two lines, or the solution point, has x equals 3. But what about y? Because we already know that x is 3. But what about the y? Well, to find y, since we already know x equals 3, all we gotta do is substitute x equals 3 into either of these two equations. Again, it doesn't matter which one you plug it into, because again, these two lines are the same at x equals 3. So the y value is the same to either of these if you plug in x equals 3. So let's just use the easiest one. Let's just use the y equals x minus 2. So x is 3. That's what we just found out. But what is 3 minus 2? 3 minus 2 is just 1. So the y-coordinate for the solution is 1. So what is our solution? Our solution is 3, 1. That point is a solution to both linear equations. When we graph those two lines, they intersect at 3, 1. Okay, so now here's another example of a system of two linear equations, and we're going to use the substitution method to find the solution. Now, this example is slightly different than the previous two examples we just saw. Instead of the variable y being already isolated, we see now variable x being isolated. X is equal to 3y plus 1. Since x is equal to 3y plus 1, we now have a substitution not for y this time, but for x. X is equal to 3y plus 1. Therefore, we can substitute x for 3y plus 1, because that's what x is equal to. So what do we have? We have 2 times x, but what was x equal to? It's 2 times 3y plus 1. That right there was the substitution process. We just substituted x for 3y plus 1. Now we have 2 times 3y plus 1 plus 4y has to equal 12. And there we go. Now all we gotta do is now solve for the variable y. We're gonna use the distributed property of 2 times 3y, which is 6y, and then 2 times 1, which is 2, plus the 4y has to equal 12. Now can we combine something? Yep, 6y and 4y combines to be 10y, plus 2 has to equal 12. Now we're just going to subtract 2 both sides, bring down the 10y, then divide both sides by 10. So what do we have? We have y to be equal to 1. Y is equal to 1. Now that is half of the solution that we need, because remember, we want the coordinate x, y. That is the solution to the system of two linear equations, or where these two lines intersect. So we have y equal to 1, not x. So now how do you find x? Since we already know that y is equal to 1, all we gotta do is substitute y equal to 1 to either one of these two equations. It doesn't matter. But which one would you pick? I would have picked this equation because that one looks a lot easier to plug in y equals 1 than the very first equation. So let's go ahead and do that. So we see x is equal to 3y plus 1. Now y is 1, so we're going to substitute the value of 1 into y. 3 times 1 is just 3. Then 3 plus 1 has to be 4. So the solution to the system of two linear equations, or where these two lines intersect, must be 4, 1. X equals 4, y is equal to 1. Alright, so this is our final example of solving a system of two linear equations using the substitution method. Now, unlike our previous three examples, none of these equations has a variable isolated. I don't see an equation that says x equal to something or y equal to something. However, one of these equations is actually very easy to isolate for either the variable x or for y. In this example, the second equation is actually very easy to isolate the variable y. All I gotta do is one step. To get y by itself, all I gotta do is get rid of the negative 5x. We're going to add 5x because that's the opposite of a negative 5x to both sides. So what is y equal to? Negative 3 plus 5x, or just 5x minus 3. And there you go. Now we have an equation with the variable y isolated. Since y is equal to 5x minus 3, we now have a substitute for the variable y into our first equation that we just see. So since y is equal to 5x minus 3, we can substitute 5x minus 3 into y. So now what do we have? We have 3x minus 8 times y. But what is y? Y can be substituted as 5x minus 3 because that's what y is equal to. So y is 5x minus 3. This expression has to equal 24. And there you go. Now we just gotta solve for x. Let's go ahead and use the distributive property of multiplying negative 8 to both terms. So we have 3x, and negative 8 times 5 is minus 40x. Negative 8 times a negative 3 or a minus 3, two negatives or two minus signs makes a positive 24. Equals 24. Okay, so now can we combine like terms? Yes. 3x minus 40x is going to be negative 37x. Now we're just going to solve for x. Minus 24 both sides. We have negative 37x equal to 24 minus 24, which is 0. So then we're just going to divide both sides by negative 37. Then we get x is equal to 0. Now, what about the y value? We're just going to substitute x equals 0 into either of these two equations. Let's just go ahead and substitute x equals 0 into the second equation. In fact, let's just substitute that into the equation that we had a variable y already isolated. So y is equal to 5 times x, which is 0, minus the 3. So now what's 5 times 0? It's just 0, minus 3. Now 0 minus 3 is just negative 3. So what's the solution? What's the intersection point for these two lines? It's just x equals 0, y is negative 3. And there you go.